hope everyone is doing well. I'm going to talk about how to break apart a front-end application from monolith to micro. Okay. Oh, it skipped one. Okay. To start with, let me introduce myself. I'm Thayse Onofrio. I'm based in Brazil, so very long trip. Very excited to be here for the first time on the West Coast. I'm a lead software engineer at ThoughtWorks. I'm someone who is very passionate about front-end technologies, front-end architecture, and practices we can use to build better software, and that's why I'm here today. You can find me at thayseonofrio.com and Thayse Onofrio on social networks. So, let's start talking about a case that commonly happens in teams, and specifically here talking about front-end, the monolith front-end. So we can start thinking about our web application. This is our banking web application. We are looking at a page that displays the savings account information of a user. And on the top of the page, we can see a profile component. So this is the page that we are working with. Initially, this profile component is very small, so it was built within the savings account application. We can think about it this way. So the both applications are built together, even though we have a separate functionality for the profile component. As it was very small, that's how they built it. But the savings account page is owned by the savings team, so this team is responsible for maintaining it and adding new functionality to it. And the profile team owns the profile functionality. They have a team that will be responsible for handling it because they want to start increasing this functionality, so adding new things to it, improving it. And their initial solution is to continue as it is. Since everything was built together, they will start working this way. But as the time goes by, this starts to become a challenge for the teams. So both of the teams are completely separate, but they are working on the same code base. And they have different standards, different processes. So they start getting into each other's toes all the time. They work with PRs, so when they open a PR, they need the other team to review it to make sure everything is good. And sometimes there may be some blockers, so they end up blocking each other all the time. And they start facing a few issues. Some of the problems they start to have is each team has different code standards and processes, as I mentioned. So one team will commit one thing one way, the other team in another way, so it starts to become messy. There is not really a lot of communication between the teams. They work with they have different ceremonies, they have different processes, so they don't really talk to each other unless they really need to. They are also sharing the same pipelines now, so the pipelines are busy all the time, not really a lot of resources to handle everything they need. There is a lot of conflicts because they have this lack of communication, so one team doesn't know what the other team is working on, so they might end up breaking each other's code frequently, and a lot of communication conflicts as well. And one of the main pain points is the dependency on the deployments. Because right now, if the profile team wants to make a change to production, they need to check with the savings team first if everything is okay, if they don't have any issues, anything that is blocking them from deployment. And sometimes there are blockers, so they can't really get to production because of the other team, and the other way around. So you can imagine all the conflict that this is creating for them. So they need to continue growing these both functionalities, and they are pretty sure it is not sustainable to continue like this, especially now with the new functionality that they need to start growing. So that's when they realize it's time to start disintegrating. They need to find a better way to do this, and the approach that they start talking about is micro frontends. So micro frontends is an architecture composed of smaller front-end applications. They are developed and deployed independently, but they display this unified user experience. So as a user looking at that web application, I don't know how that was developed, if it's 2 or 3 applications. It's just the same thing for me. I should be getting the same experience. So if the teams start to go to this approach, we would have the savings account web page as one application, and then the profile component would be its own application. So each team would be able to have a lot of ownership on it, develop and deploy independently from each other, and avoid all those conflicts that we were seeing. So they would have a lot more independence and a lot less conflict. Besides each team having ownership of their own applications, there are other benefits with micro frontends. So there is scalability. It's easier to scale only the parts of the application that you really need to. It's easier to maintain as well, so easier to make changes to everything and to add new functionality to it. And also easier to adopt new tools and tech because you don't have this dependency between other teams and you have a lot of ownership of what you are developing. Cool. We understand all the benefits that we can get from using micro frontends, using this architecture. But how do we get to that once we are in this monolith front end, possibly very tangled code, a lot of teams working on that for some time, to this new approach of micro frontends? We could start thinking about, should we start from scratch or evolve what we already have? It's very tempting to start from scratch. Like we could stop working on everything, start everything from the beginning, but that's just not possible. That's just not the reality for most cases. We need to continue maintaining whatever we have in production, probably something critical that needs to be there, needs to be maintained, add new functionalities to it. So we can't just stop working on it and start from the beginning. Most likely, we need to find a way to evolve what we already have and continue to improve that without affecting the user experience. So once we decide we will evolve what we already have, the first thing we need to do is to start defining the boundaries. We can start analyzing what could be decoupled, what parts of the application could be decoupled from each other. And to do that, we can think about how users interact with the page. And then we can start defining those boundaries. And to do that, we can think about bounded contexts. In this example, it's a bit obvious for us that profile should be its own app, while savings app should be its own app. But that part of analyzing it, it's usually very complex, especially in a big application. So we can use the domain-driven design, DDD concept of bounded context for that. So the bounded context is a way for us to define physical and ownership boundaries. And each bounded context should be implemented as an individual service. It should be evolved independently from other bounded contexts and maintained and owned by individual teams, which is basically what we want to achieve here. And for bounded contexts, even if each one is separate from each other, they should work together to create a system. So basically what we want. Okay, we know we want to go that way. We know we want to separate profile from savings app. But how do we actually do that? There are many different approaches to do that, but I would say to first start small and take incremental steps. And what would look like, starting small would look like in this case? We could start very simply extracting the profile feature, so it would have its own repo, its own pipeline, and then publishing it as an NPM package, for example. And then the savings team could just install it and display it on where we should be seeing that component. And you might be thinking, does that make it into a micro frontend? Probably not. But it's a step towards that and with minimal effort. With this change, we are able to solve some of the issues that we were having. So now the teams are working in separate repos. They don't need to worry so much about breaking each other's codes. They have way less dependencies between each other. But they still have the dependency on the deployments and the dependency to upgrade the package version now. Because if there is any changes on the profile team, they need to upgrade it and publish this new version. The savings team needs to install it, and they have this dependency on upgrading it and deploying. But we were able to move on from that, and now we can start to think about how the apps are composed together. And with thinking about that, what we want to achieve is independent deploys. So we can get to that micro front-end approach. Right now, we are doing this installing and publishing, but what we want is to be able to have these independent deploys. And to do that, there are also several approaches, but here we'll talk about module federation. So module federation is a Webpack functionality. A lot of teams that use front-end technologies are already using Webpack as a module bundler, so it can be very simple to get started with module federation because of that. So instead of publishing the package and installing it, we'll be able to deploy the two applications separately and then connect them through a host and remote approach. Let's take a look at how that would actually look like. So here we have the profile app Webpack configuration file that would already exist in this case, and we are just adding a new plugin, the module federation plugin. And here we are saying that we expose the app in a file name called remote entry.js. So basically, that's the simple configuration we need to do. And when we bundle this and deploy it, we'll be able to access this remote entry.js file. And then on the savings app, very similar to that, instead of exposing the app, what we want is to say we are connecting to a remote for the profile application that is available on this specific port on the remote entry.js file. So with the simple configuration, we are already able to have this communication between the applications. And then on the savings app, on where I'm going to use the profile app, I can just literally import it, as I would do with any other app that is installed, any other package that is installed there, and display it whenever I want it. Cool. We were able to solve a lot of the issues now, and we get the independent deploys with some small configuration that we did. But what if you want to load the profile app under a specific condition, like using a feature flag or maybe using it in an A/B test? To do that, we can continue to use module federation, but we can expand our approach a little bit to use dynamic remote containers. So here, we don't change anything on the profile app. It continues to just expose itself. But on the savings app, I'm going to just import the remote entry.js file, just adding a script tag in the HTML. So when we load the page, we will be able to load the remote entry.js file. And then we have a JavaScript function that we can use to interact with the Webpack API directly. So we don't even need that Webpack configuration here. We are just going to interact with the API directly. It will be available on the window object. We have the profile there. And then we are able to initialize this container. So then to use it, we just lazy load it and import it here. And we are able to choose a flag for that. So here I have a should show profile flag. And I will only import this file if this flag is enabled. So it gives us a lot more flexibility about when to load it and when to not load it. Cool. So we were able to solve all the issues we had so far. But we need to think about what happens now if there is any issues with the profile app. Currently, it means that the savings app would not be able to start as well. So we created a new issue of strong coupling. One app actually depends on the other to stay up. So we add this new issue to our list. And we need to think about strategies to deal with that. And one way to do that is use promise-based dynamic remotes. So it's still using module federation and Webpack. The profile app continues to be the same. It just exposes itself. But on the savings app, we will now use interact with it. And instead of using the HTML direct script to import the remote entry.js, we'll dynamically add it here. And we will be able to easily choose where we want to load this remote entry.js from, probably having different URLs for different environments. And we are able to add event listeners to it. So here we can choose what to do when to initialize this container, but also what to do when there is an error. So we can choose to not show anything if there is an error, just let the user interact with the savings app, or we can choose to retry, or we can choose to add some fallback strategies to show an error message. We can deal with it whatever way we want, while not affecting so much the user experience. So here is an example. You can see this beautiful app that I created. So here we are loading the profile app on port 3002, and that's all that it loads. And then if you go to the other port, 2001, we are loading the savings app, which is also loading the profile app. So as a user looking at it, it doesn't really matter to me that it's two applications. But under the hood, it's actually two things being loaded. So just as an example, we see here in a really slow motion that we load first the savings app, and only then the remote entry.js file is loaded. Let me just put that again. The remote entry.js file is loaded, and only after that, the profile app is initialized. So here is on purpose very slow. But this gives us a lot of flexibility about when to load it, how to deal with any issues, and just basically gives us more flexibility to deal with that. And so far, we've been talking about the savings app being the one that will control when to load the profile app and what to do if there are any issues. But ideally, this shouldn't be a concern of the savings app. The savings app should just be a micro frontend that exposes itself. And we can have a shell app that is responsible for composing the micro frontends together. So each micro frontend can just expose itself, and the shell app can handle loading them, where it should be loaded, if there are any routings, any fallback strategies, error handling. So the shell app can be responsible for any composition, and the micro frontends really don't need to worry about that. Cool. So with this approach, we were able to solve all the problems we had. But we know that's not all. Every time we add something new, we need to think about the new challenges that we have. And there are some new challenges that we can introduce, and we need to think about those trade-offs when using the micro frontends approach. Some of the new things to worry about that we have, and the first one is sharing data. Previously, each micro frontend was loaded just as an app, so it would call an API to get data and be able to display that wherever it wanted. But now, having two separate apps, it doesn't really make sense for each app to call the same service, to display the same data, and do that twice. So we need to think about how they can share this data. And there are many strategies that they can use to do that. They can also share some information like events. So, for example, if I have icons button on the component part profile, and I want to click that to show or hide sensitive information on the savings app, there needs to be communication between the two apps to know when to do that and when not to. So to do that, we can choose to use events on the window, like subscribing to the event and being able to react accordingly to it. To share data, maybe you can choose to use Redux, but then you need to think about the other apps changing the same context. So this is a new issue that we introduce, and we need to be careful about it, how we are sharing data, what data we are sharing, and maybe if we need to share too much data, maybe that's an indication that those apps should not be separate. So that's something to consider from the very beginning. Another thing we need to worry about is having duplicate dependencies. Previously, we were just going to a URL, loading a web page that would load a bunch of JavaScript dependencies. But now, if we have two separate apps and they have different dependencies, the user would be downloaded way more things. So that can really affect performance, and we need to be careful with that. And one thing, a lot of people can say that one of the advantages of micro frontends is that each team can have their own tech stack. So you can have one team using Angular to do something and another using React and so on. And that's true, you can do that. But you really can introduce this issue as well of having to download way more dependencies and affecting performance. So that's something that really needs to be thought about before choosing to go that route. And even if you use the same frameworks, the same libraries, we need to be careful about versioning. Because what can happen if one team is in one version of a library and the other in another version, and then you compose those apps together, something weird can happen when you do that. So you need to be careful, and there needs to be a lot of communication and coordination to make sure we are not introducing any issues with the dependencies. And another challenging we need to think about is testing. Even though we could have a great testing strategy before or for each application separately, now we need to think about how to validate that the composition is happening correctly. And we might need to leverage more other types of tests, like contract tests, functional tests, to be able to validate that. We also need to think about who is responsible for doing that testing. Because, for example, if the profile component gets loaded with the savings app, but also it's displayed in different views with the checking account application or other applications, is the profile team that should be responsible for doing all the testing and validating the composition? Or is it the team that handles the shell app that is responsible for composing applications that should be testing all of that and making sure that the composition is happening correctly? Or even other team? So that needs to be discussed, and there needs to be ownership of those kind of validations to make sure that they are happening and that we are composing things as they should. Cool. So we talked about how to disintegrate a frontend. So we can start by analyzing the trade-offs. So we can think about all the benefits that we talked about, but also all the issues that we might be introducing, all the new challenges, not exactly issues, but new challenges we need to think about. So we need to really think that through and make sure that the issues that we are having we can solve with the micro front-end approaches, and that we are okay with the new challenges that we would be introducing here. So we need to make that conscious choice. And when we do that, we can start thinking about determining the boundaries. So thinking about bounded context and analyzing how we can decouple the applications and making sure that we are doing the right choice there, not going too far as well. So thinking a lot about that, which can be challenging, but it's a very important part of the process. And once we do that, then we can choose the approach. Here we used module federation as an example, but there are many different approaches that can be used for micro frontends. We can do a horizontal split, a vertical split. We can do everything on the server side, everything on the client side. So in that part, it's very important to dig deeper into that to make sure you are choosing the right approach, and also an approach that makes sense for your team. So depending on the expertise of the team related to the tech stack, it might be easier to go towards one approach or the other. So that's something that we need to be thinking about. And after we choose the approach, we can take incremental steps. So start small as much as possible, and then you start to increment on that. Here we talked about first extracting the application into a different repo, and then publishing it, and then after that we started going into module federation and improving on that. So depending on the approach you choose to do that technically, starting to think about how you can do that small, and then using a lot of feature flags or any other strategy that you want to make sure that while we do that, we are not impacting the user experience, but also we are able to get value of the changes that we are making. Cool. And one final thought is that micro frontends won't solve all your problems. Much like microservices, the micro frontends architecture is not bulletproof. So there are challenges mentioned and much more that we can introduce with this approach that weren't issues before. So we need to really think about the trade-offs and decide what architecture to implement here. And if deciding to use micro frontends, really diving deeper into the approaches to make sure we are choosing the one that works best for our team and start to experiment with that. So this approach has the downsides, of course, but it can be very beneficial for the team. So if you are having issues like the ones I mentioned or other issues that you think that can be really helped with the micro frontends approach, I would highly encourage you to try it out and see for yourself the value that it can bring. Thank you very much. We don't have time for questions, but I will be available at the office hours, or if you want to come talk to me, please feel free. I'll be around.